Hi, it's me, Ms. V, and welcome back to another video. Today we're going to be talking about one other way to prove Pythagorean theorem using triangle similarity. So how can we create similar triangles essentially to help us prove Pythagorean theorem, okay? So over here we have a figure. So we have a right triangle ABC, and we're going to label this as triangle 1, okay? So I'm going to go ahead and label A and B because those two corners were not labeled. Okay, so we have our two angles A and B, and across from angle C, this is our right angle, we have side C, okay? So this is going to be triangle 1, okay? Now notice here below, we're going to go ahead and draw a perpendicular. So we're going to draw, and I'm going to draw the perpendicular in pink, okay? So we're going to draw CD perpendicular to line AB as shown in the next figure. So essentially from angle C, I'm going to go ahead and draw a straight line that forms a right angle with this side AB here, okay? So right here we have a right angle, okay? Next, I'm going to label the red triangle as triangle 2 and the blue one as triangle 3, okay? So in the picture, notice how many triangles do you see? We see 3 different triangles, right? We have the bigger triangle, the original one, ABC. And then after drawing that perpendicular, we form triangle 2 and 3 separately, right? And of course, they're all going to have right angles because that line, that segment CD is perpendicular to AB, okay? So we have 3 triangles. And the question says, why are the 3 triangles similar to each other? So remember, for triangle similarity, you essentially just need 2 angles in your triangles to be the same in order to show that the triangles are similar, right? So let me erase the perpendicular I drew up here in triangle 1, okay? So if we focus on triangle 1, we know that triangle 1 has a right angle, okay? So this is one of the angles that's the same in both of them, in all 3 of them actually, right? All 3 of the triangles have that right angle. Maybe let me not draw it in pink. Let me pick a different color because you can't really see it on the other ones. Let's do purple, okay? So this angle 1, we have it here. We have it here in triangle 2, and we also have it right there in triangle 3, right? Now, triangle 1 has angle A, which would be the second angle, and we know that the blue triangle, triangle 3, also has that angle A the same. So we know that this triangle 1 and triangle 3 are similar because they have the right angle and angle A in common, right? Similarly, the red triangle, instead of having angle A in common, it has angle B in common with that first original triangle. So we'll call this angle 3, okay? So now in the red triangle, we have the right angle, which is the first angle, and the angle B, which is the second angle that they have in common. So essentially those 3 triangles are all similar to each other because they all have 2 angles in common, okay? So now we're going to go ahead and compare triangles 1 and 3. So triangle 1 is the original triangle in green, okay? And then triangle 3 is the little blue one, okay? So triangle 1, okay, so if we compare those 2 triangles, we can see that we gave different side lengths over here, and you guys might not be able to see that, but this is B, this is C, and this is A. This is Q, K, and B, okay? Because they both have AC in common. See that, AC and AC. Okay, so now here, if we were to compare the sides, we know that C over B is equal to B over Q, right? This is the right angle is over here and here, okay? So this side is similar to this side, and Q is similar to B. So if we divide C over B, that should be equal to B over Q. And then if you cross multiply, so we're going to go ahead and cross multiply these 2, right? We get that B squared, or B times B, is equal to C times Q, okay? So we're just going to go ahead and table that for a second. So we know that's true for that triangle. Now we're going to compare the original triangle 1 with triangle 2, the red one, okay? Again, here, this is B, this is C, and this is A. And now this is A, this is K, and this is P, So all we did was basically give the sides different letters. I would go back to the original one and show you guys where the sides are, but I think it might be a little confusing. Now from here, we're going to cross multiply again. Okay, so now in this example, they compared C and A. So C over A equals A over P. You cross multiply, you get that A squared equals CP. Over here, we had B squared equals CQ. Okay, so remember those two. All right, so now if we were to add them together, right, we knew that A squared was equal to CP, and we knew that B squared was equal to CQ. So if we add A squared plus B squared, that's the same thing as saying CP plus CQ. Okay. Then from here, which is this line right here, right? Then from here, notice, right? You can go ahead and factor out C, right? You can divide both of them by C and take it out, and then leave P plus Q behind in parentheses. So instead of distributing, right? Because notice here, when you have parentheses, you would distribute, right? You do the opposite of distributing and you factor instead, then you get C is equal to P plus Q. And now here, if we focus on the picture down here, they gave us some different side lengths, P and Q here. This was B and this was A, because this was the right angle C. So notice here, right, P plus Q, this whole side here in the first original triangle was actually just C, side C. So we can substitute P plus Q for C. So now here we get A squared plus B squared equals C times C, because P plus Q equals C. So now finally we get the formula for Pythagorean theorem again, but instead of using the first method that I used in my 2 videos ago, we're using triangle similarity instead, okay? So we have an example here of a Pythagorean theorem application question. So let's go ahead and read this. So me and Tyler were standing at one corner of a large rectangular field. So I'm going to draw a large rectangular field. Whoops, I always forget that I have to draw the whole field together. There we go. Okay. So Mia and Tyler, let's put Mia in one corner. And Tyler is in the same corner with her. So they want to race across the field to the opposite corner. So Mia had a bike, Tyler did not. They thought it would be more fair if Mia rode along the sidewalk that surrounds the field, while Tyler ran the shorter distance directly across the field. The field is 80 meters long, so let's go ahead and label that 80 meters long by 60 meters wide. Tyler can run at around 5 meters per second, and Mia can ride her bike at around 7.5 meters per second. Okay, before making any calculations, who do you think will win the race and by how much? Explain your thinking. So essentially here, right, this problem we have, first we want to figure out the distance, right? We want to figure out this distance across, because essentially what Mia is going to do is Mia is instead of going across and she has her bike, she's gonna ride horizontally, and then she's going to ride up vertically to meet at the same corner here. Tyler's just going to run straight across, okay? So what I want to do is I want to figure out this distance that Tyler's going to run across to kind of see who might win, okay? So you guys can guess who's going to win. I think that Tyler might win, but we shall see. So let's go ahead and calculate that distance across. We know that it's a rectangular field, so these are right angles. So this right here is my hypotenuse, which means I'm going to go ahead and use Pythagorean theorem to figure out what that distance is, okay? So A and B, okay? A, we'll say A is 80, and that B is 60. Okay, and now we're going to go ahead and grab our calculator and do 80 squared, which is 6,400, or 6,400, plus 60 squared, which is 3,600, equals C squared. That's going to be 10,000. Yep. I'm just going to write it down here. And now we're going to take the square root of 10,000, which is going to be 100. Okay. So the distance directly across is 100 meters, okay? Now, this is the part where it can get a little bit tricky because now we know that Tyler is running at 5 meters per second, okay? So I know Tyler's distance, he has to run 100 meters and he runs at 5 meters per second. So every second he's gonna run 5 meters, which means I'm gonna go ahead and divide 100 meters by 5 meters per second, okay? Because I want to figure out how many seconds it's going to take him to get across the field, okay? I know that he runs 5 meters every second. So if we divide 100 by 5, then we're going to get 20. So it's going to take Tyler 20 seconds to run across the field. So this is Tyler. And now Mia, she has to ride not 100, but she has to ride 80 plus 60 meters. So Mia, we're going to add 80 plus 60. Mia has to ride 140 meters, but she rides this distance in 7.5 meters per second, okay? So now that 140, I'm going to divide it by 7.5 meters per second. So Mia gets across the field in 18.7 seconds, okay? So it looks like Mia got across the field faster than Tyler did, despite the fact that Tyler went the distance across, okay? So the winner of this race is Mia. Okay, so this is basically one way that we use Pythagorean theorem. You can also think of an application question as driving a car, right? So if you're, you have to drive 6 miles and you drive at 50 miles per hour, then, how fast is it going to take for you to get there? So if you guys have any questions, as always, please leave a comment below and I will get to your question ASAP as possible. And I will see you guys in another video. Bye.